Hello everyone and welcome back to another Unreal Engine 5 tutorial. Today we take a deep dive into a new feature introduced in Unreal Engine 5.7, the Procedural Content Editor Tools. With this, we can now create PCG directly in the level without setting up complex graphs. First, make sure to enable the Procedural Content Generation plugin. After that, you'll find the PCG mode in the drop-down menu. Let's start with the Spline tool. Under Draw Spline, we have three different tools. The first one is the Spacing tool. To begin, just draw a random spline inside your level. One important thing to keep in mind. If you accidentally click in the viewport while drawing your spline, it will reset and start a new one. Unfortunately, this cannot be undone. This actually happened to me quite a few times. You just want to adjust the camera and suddenly your spline is gone. So, once you're happy with your spline, make sure to press Accept before doing anything else in the viewport. Anything that is not confirmed will be lost. To actually see something, let's first add a mesh in the spawning section. Enable Static Mesh and add a new element. I'll use a simple cube for now. Now open the sampling section. With Count, you can define how many meshes will be spawned along the entire spline. Alternatively, you can enable the Distance Sampling mode and set the distance between each mesh in centimeters. Fit to Curve adjusts the spacing so the entire spline is filled evenly, which means the first and last mesh will sit exactly on the first and last spline point. Start and end offset are pretty self-explanatory. With Max Random Offset, you can add some variations to the spacing, and the sampling seed controls that variation. Back in the spawning section, let's add a second mesh. This time I'll use a simple sphere. With the weight value, you control how often each mesh appears along the spline. The values are relative, so if both are set to the same number, they will be distributed evenly. Increasing one value simply makes that mesh appear more often than the other. You can also spawn actors instead of meshes by specifying an actor class here. In the Global Transform section, you can apply a fixed offset, rotation and scale to all spawned meshes. The Random Transform lets you define a range for each value and then applies random offsets, rotations and scales within that range. And again, the random seed simply controls the variation. In the Projection section, we have Snap to Surface, which should move the pivot of the meshes onto the surface. But as you can see, it's not working. That's because PCG only works with static objects, and the floor in this default level is set to movable. Just change it to static. Now, if we select our PCG actor again, reopen the Spline tool and enable Snap to Surface, it works as expected. This overrides any Z offset from the global and random transform settings. Align to Surface adjusts the rotation to match the surface normal. You can also define the maximum distance within which the snapping will work. In the spline settings, we have the Close Spline option, and we can choose the Draw mode. Right now we're in Free Draw mode, but there are two additional modes. With Click Auto Tangent, each click creates a new spline point with automatically generated tangents. In Tangent Drag mode, you can click and drag to manually define the tangent. In Free Draw mode, you can also set the minimum distance between generated spline points in the world space. And Reset will delete the current spline. Finally, in the Raycast Rules section, you can define which surfaces the PCG meshes should spawn on, for example, landscapes, static meshes, or other PCG components. The Draw Target defines the direction used for projection onto the surface. In most cases, you can just leave both settings at their default values. Now, let's take a look at the Linear Grammar tool. Here we have a new section called Modules. In this section, you assign a static mesh and give it a symbol, which basically acts like an ID. If you use multiple meshes, you can define how they are placed along the spline using the Grammar section. The modules are separated by commas, and you can use a multiplier to repeat them. For example, writing B times 3 will spawn mesh B 3 times in a row. This way, you can define a specific pattern of meshes along the spline. If you don't specify a number for the last symbol, it will continue repeating until the spline is filled. Also, you can define a module size for each mesh individually. Or simply use the mesh bounds as the module size. You can also define if the mesh should be scalable, choose the forward axis, invert the axis, or reverse the orientation. You can set a local offset and rotation for each mesh and enable collision. In the spawning section, you can switch to spawning spline meshes instead of static mesh instances and control their behavior with the available parameters. What a spline mesh is, I will show you in a moment. Debug mode will spawn simple cubes instead of the actual mesh, which is useful for testing. You can also assign an individual debug color for each mesh in the Modules section. All other settings in this tool are the same as in the Spacing tool. This tool is great for repetitive setups like fences or walls made up of different elements. Or for something simple like placing a line of lanterns with a bench in between. So the last of the three modes is the Spline Mesh tool. Here you can assign a mesh and choose its forward axis to generate a spline mesh based on its shape. You can also resample the spline with a different distance value to smooth it out, for example. This is very useful if you want to create roads or things like pipes and wires. And keep in mind, this is fully procedural. You can edit the spline points at any time, even outside the PCG mode, and everything will update automatically. And there is another spline mode called Draw Spline Surface. Here we get access to the Area tool. Let's add a simple cube first, so we can actually see what's going on. With this tool, we can draw a closed spline that defines an area which will then be filled with meshes. In the sampling section, you can define how many points per square meter will be generated. You can also adjust the point size, which effectively controls the minimum distance between the meshes. Uniformity is a value between 0 and 1, where 0 is completely random and 1 is perfectly uniform. Next, we have the filtering section, which controls how many of those points are actually kept. The probability filter lets you reduce this amount based on a percentage. Alternatively, you can enable the fixed count filter and define an exact number of points to keep. You can also define an edge fall-off in centimeters. The fall-off power adds an exponential curve to this fall-off, where the value of 1 is linear. So this basically controls how strong the fall-off effect is. The fall-off filter determines how much of the effect is applied, where 0 means no filtering and 1 applies it fully. Remove overlapping points removes overlapping points based on the defined point size. this only affects the generated points, not the meshes themselves. So, the overlap check is based on the defined point size. That means, if your mesh is larger than the point size, they can still overlap. And if they are smaller, points might get removed even though the meshes wouldn't actually intersect. Alternatively, you can use the mesh bounds instead. And the rest works exactly the same as in the other spline tools. This mode is very useful for creating areas with trees or other vegetation, or for scattering rocks across the ground. And that's it for all the PCG spline tools. In the next part, we'll take a closer look at the paint and volume tools and how to use them to create more complex environments. So, if you want to take this even further, make sure to check that out. Cheers!